All right. Hey, welcome everybody. Happy you're here. Today we're going to be talking about chemical reactions. And before we get started, it's worthwhile talking about how we got to this point. And just a reminder, I know it's been a little bit since we've been in school, but just a reminder of how we ended up at this point. See, when we started this thing off, we were starting from the smallest particles and then moving our way up into compounds. So this is what we've got so far. So let's just take a look here. So this is where we started. Actually, let's go to this guy here. Let's go here. Perfect. So we started talking about elements first. And really, we started talking about the subatomic particles first. We started talking about protons, neutrons, and electrons first. And that was where we started this whole thing off. We started talking about how different protons, different number of protons gave us the different elements. We started talking about how different numbers of neutrons gave us the isotopes. And we started talking about how different electrons gave us our different ions. And so then we started talking about the periodic table, and we talked about sort of the two major categories of metals versus nonmetals, and how they had different properties, and we could predict what their properties were going to be like based on whether it was a metal or a nonmetal. Then we started combining our elements to make compounds. Now, there are three main ways that we did that. Way number one, we started talking about ionic compounds, which was the metal and a nonmetal. Then we moved into molecular, metal or nonmetal and nonmetal. And then finally, we finished up with acids and bases that had their own set of rules and naming. So all of this leads into our next thing where now we're going to start talking about reactions. When you take different compounds, different elements, and combine them together, we're going to be looking at how do we predict what they create, and we're going to be looking at and how do we write that so it makes sense for everyone. So to do that, we need a couple things of terminology. So the first thing we need to talk about is some language around it. Now, when we talk about writing chemical reactions, we're talking about really two parts of it, the reactants and the products. All right, the reactants are the things that we are combining, and the products are what they make. Think about it this way. If I have a math formula, and let's just do something really simple here. Let's go 1 plus 1 equals 2. All right, this side here, this side with the 1 plus 1, these are my reactants. These are the things that I'm combining to create this side here, my product. So reactants and products. And if I were to say this out, I would say 1 plus 1 equals 2. Chemistry has a really similar thing. Instead of using an equal sign, though, we use this arrow here. And this arrow shows us the direction in which the reaction is taking place. So we say that we're combining these two together to create this product. And so if we were to read this, we would say 1 plus 1, and this arrow here, we give it a name, we call it yields. That's how we would say that. So 1 plus 1 yields 2. So we always go from our reactant to our product. But occasionally, and as you'll learn in future chemistry courses, it can go the other way as well, where it goes from the product back to the reactant. That arrow can go both ways. So we would write that as 1 plus 1 yields 2. So let's look at a really simple example to start off here. Let's go back into our notebook here. Let's look at this one. I've written this one out as A plus B gives us AB. Now, this A could be any compound or element. B could be any compound or element. But it's the same idea. Reactants on this side, and we've got our products on this side. A plus B gives us AB. Now, we're going to look at, over the course of the next two videos, we're going to look at these two things here, something that every reaction formula needs. One, we need to talk about the state in which that particular compound exists. So remember, we've talked about solid, liquid, gas, and then we added this one in when we talked about acids and bases. We talked about aqueous. And so every chemical formula needs to have, or every reactant or product in our chemical formula needs to have a state. So for example, and we'll talk about in the next video, how do we determine what the states are? But the states always get written down to the right of the compound in subscript. So let's just call that a solid, let's call that a liquid, and let's for fun call this one aqueous. Now, like I said, in that next video, we'll talk about how do we determine what those states are. But for right now, I just made these ones up. So A is a solid, B is a liquid. We combine them together, and that makes this one aqueous. That makes AB aqueous. And so each compound needs to have a state on it. That's number one. The second thing that each compound needs to have is it needs to have what we call a coefficient. And the coefficient is a number that goes right before our compound in those spots there. So I want you to think back to math. We talked about coefficients in our sort of our polynomials unit. And the coefficient tells you how many of each thing that we had. So if I had, let's make this a little bigger here. If I had 2 of that A compound, whether that's an element on its own or whether that's a compound, if I have 2 of those there, all right, I would have a coefficient of 2. Now, if the coefficient is equal to 1, we don't need to write anything in there. So in fact, if I said I just had 1A, I would just leave it as A there. But if I had 2 of them, I would put that 2 up front. Now, we're going to talk about why this is important when we start balancing equations a couple videos from now. It's sort of like the last big important thing that we need to do when it comes to our chemical formulas for the purposes of this class. So you need to have your reactants on one side, your products on the other side, not an equal sign, but a yields arrow. All right. You need to make sure that in every formula, you have your state identified. You need to make sure you have your state identified, and you need to have coefficients in there as well. So you need to have all of those things in every chemical formula you write. So here's what we're going to do. At the end of this video, which part of the formula are the coefficients? This is terminology you need to know. And then in the next 2 videos, we'll talk specifically about how do we determine state if we haven't been given it directly, and we will talk about the coefficient. So we'll see you in the next video. Good luck.